strategies, let's now calculate the expected value of this game, the expected utility of this game for rho. And we'll know, of course, that the expected utility of this game playing these strategies for column is exactly the opposite of that number. Okay, so first of all, what is the probability that they're going to wind up on this particular point in the matrix? Well, 3/4 of the time, rho is going to play the strategy R1, and 1/3 of the time, column is going to play the strategy C1, and when they do, that's going to be worth -2 to rho. What is the probability that they're going to wind up here? Well, 1/4 of the time, rho is going to play, 3/4 of the time, rho is going to play R1. 2/3 of the time, column's going to play C2, and when they do, that's going to wind up with a value of 1 for rho. 1/4 of the time, rho is going to play R1, so 1/4 of the time, and then 1/3 of the time, column is going to play C1, so in that case, they'll wind up with a value of 6 for rho, and 1/4 of the time, rho is going to play R2, and 2/3 of the time, column is going to play C2, and so in those instances, they're going to wind up with a value of -3 for rho. So now when we calculate this out, we will have the expected utility for rho under these strategies. We will get 3/12 times -2, which equals -6/12. We will get 3/4 times 2/3, that is 6/12 times 1 for rho, or plus 6/12. All right, we will get 1/4 times 1/3, that's 1/12 times 6 for rho, that's 6/12. And we'll get 1/4 times 2/3, 2/12 times -3, that's -6/12 for rho. And when we add this all up, you see that we get an expected value of 0 for rho of this game, and so we know the expected value of column for this game is also 0. So if both of these players play their part of this mixed strategy, they can end up with a security level of an expected utility of 0. That is, they can expect over many plays playing these strategies to wind up breaking even. And any other choice they make, any other choice rho makes or any other choice column makes, can be exploited by the other player. If column simply decides, to heck with it, I'm going to play C1 all the time, well, rho, or I'm going to play C2 all the time to take that shot at -3, well, rho will then immediately change to a strategy of playing R1 all the time, and now the game will have a value of 1 for rho and -1 for column. Column has reason to switch from that choice to this one. And you can work that out for every single way. So by employing chance devices with these probabilities, both can guarantee an expected utility of 0 for a game of this structure.